discuss projectile motion. Okay. So there are two kinds of motion, a motion in a straight line and the second one is a projectile motion. When a body moves under an acceleration and the direction of the acceleration is same as that of the direction of the velocity, then the body moves in a straight line. Okay, the magnitude and the direction of the velocity, increases, but the direction of the velocity remains the same as that of initial velocity. Okay. Example: if an object moves along a straight line and accelerates, like for example, we have a ball that is thrown vertically downward. Now the ball is moving in the downward direction and acceleration due to gravity is acting in the same direction, that is vertically downward. Then the velocity increases in the downward direction and there is no change in the direction of the velocity. So this kind of motion is known as a straight line motion. Clear? But if the acceleration on the object that is moving with the velocity v is different, the direction of the acceleration is different than the direction of the initial velocity of a moving body, then what happens? The direction of the moving body and its magnitude both continuously keeps on changing. Okay. So when the acceleration acting on a moving body with velocity v is different than that of the direction of velocity v, then the magnitude of the velocity and the direction of the velocity both are continuously changing. Then this kind of motion is not a straight line, it is a curved path. Then the body moves at an angle to the vertical or to the horizontal, making a trajectory. This kind of motion is known as a projectile motion. So when the body is moving at an angle theta to the horizontal, it will cover both the distance and as well as the height. I'll give you an example. Suppose in a cricket match, the fielder at the boundary throws the ball to the wicket keeper. Now what he does? He throws the ball at an angle to the horizontal. As a result, it covers certain height and it also covers distance. Okay, or a batsman hitting a six. Now what happens? It goes to a certain height and it also covers the distance to the boundary. Now this kind of motion is a curved motion and it is known as a projectile motion. The projectile motion can always be resolved into two simple motion, one horizontal and the other vertical motion. Now these motions are completely independent of each other. Here you have, there is a ball that is thrown in a horizontal direction. There is a ball which is thrown in a horizontal direction from a certain height. Now under the acceleration due to gravity, the ball moves down. And after a certain time, its velocity changes from v1 to v2. So now the ball, as it is coming down under the acceleration due to gravity, its direction as well as its magnitude both are changing. The velocity is changing from v1 to v2. The change in velocity is given by delta v. Okay, so we find out the difference of the velocity v2 minus v1, that is delta v. The important thing is that the change in the velocity is in the same direction as the direction of the gravity. You can see here, this is delta v. Delta v का direction क्या है? जो gravity का direction है. Okay. So when a ball body that is thrown vertically, that is thrown horizontally from a certain height, its velocities, magnitude as well as direction both are changing. The change in the velocity is always in the direction of the acceleration due to gravity. What is its consequence? Consequence is that if we drop a ball, from a roof and at the same time throw another ball in horizontal direction, then both the ball will strike the ground at the same time, but at different places. So अगर हम दो बॉल को एक साथ एक हाइट से छत पे से एक को ड्रॉप कर दें वर्टिकली डाउनवर्ड और दूसरे को उसी वेलोसिटी से हॉरिजॉन्टली फेंक दें, तो दोनों एक साथ जमीन पर टकराएंगी लेकिन अलग अलग जगह पर. So both will strike the ground simultaneously but at different places. Okay. Now there are certain assumptions taken in projectile motion. What? They are all throwing the things in, not in vacuum but in air. So air must be offering certain amount of resistance. So air resistance is considered to be absent. Second, the effect of curvature of the earth. Since we are not throwing a, it's not an intercontinental blasting missile, ICBM missile तो है नहीं जो 5,000 और 8,000 किलोमीटर की दूरी पे जाके गिरेगा, तो हम अर्थ के कर्वेचर को क्या मान लेते हैं? नेग्लिजिबल मान लेते हैं. Then effect of earth's rotation is also ignored. So three things are ignored. One, the air resistance is ignored. Second, the curvature of the earth is ignored. Third, the rotation of the earth is also ignored. Fourth, we consider that the acceleration due to gravity is also same all over the place. The value of g is constant. Now we will discuss the equation of projectile motion. So now we will discuss the path of projectile motion. Okay. Let us take an object that is projected upward with a velocity u at an angle theta to the horizontal. An object that is thrown with a velocity u at an angle theta to the horizontal. Okay. So let O be the initial point of projection and OX and OP represents the horizontal, OX and OY represents the horizontal and vertical axis. So we resolve this velocity. So this is the velocity u. It is thrown at an angle theta. We resolve this velocity into horizontal component and vertical component. So horizontal component is ux, that is equal to u cos theta. Vertical component is uy equal to u sin theta. Now this projectile reaches the maximum height h. This projectile reaches the maximum height h and finally drops at this point, covering the maximum range r. Okay. So it is undergoing both the motion vertical and the horizontal motion. Now the vertical motion is under the influence of acceleration due to gravity. As a result, first its height increases, then it comes down. Whereas the horizontal motion is not affected by the acceleration due to gravity. So horizontal velocity always remains the same. Let us consider that the body moves, the projectile moves for a time t. So the horizontal range that is covered by the body is given by x. X इस पे कितना मूव किया? X is equal to horizontal velocity into time. Horizontal velocity is u cos theta into t, and x is also equal to range. This is also equal to range. So range is equal to x is equal to cos theta into t. Now we find out the vertical motion. So maximum height reached by the projectile is h. This is a motion under acceleration due to gravity. So h is equal to ut minus half gt square from the equation of motion. Ut minus half gt square. U क्या था वर्टिकल मोशन में? वेलोसिटी क्या थी? u sin theta t minus half g निकाल लेंगे। टी की वैल्यू क्या हो जाएगी, x अपॉन u cos theta. T is x upon u cos theta. So we will substitute the value of t. H is equal to u sin theta in bracket, second bracket में क्या है, x upon u cos theta minus half g of t square की वैल्यू x square x upon u cos theta का होल स्क्वायर, x upon u cos theta का होल स्क्वायर. Now u and u cancelled out, h यहाँ पे कट गया, sin theta upon cos theta tan theta, x minus 2 u cos square theta. So what is it, minus 1 by 2 g x square upon u square cos square theta. Okay, so what do we get now? H can be replaced by y, so y is equal to h equal to tan theta into x minus half g upon u square cos square theta x square. Now this equation is quadratic in x and linear in y. यहाँ पर x की पावर क्या है, 2. This is quadratic in x and linear in y. So it is a equation that represents a parabolic motion. It is a parabola. जैसे पैराबोला क्या होते हैं, y square is equal to 4ax. पैराबोला की इक्वेशन क्या है, y square is equal to 4ax. इसमें क्या होता है, x की पावर 1 होती है, y की पावर 2 होती है, और यहाँ पर क्या है, x स्क्वायर इज इक्वल टू 4ay. ये दूसरा पैराबोला की इक्वेशन है, x स्क्वायर इज इक्वल टू 4ay. तो जब एक वेरिएबल की पावर 2 और दूसरे वेरिएबल की पावर 1 हो तो मोशन के साथ कर्वेचर कैसा होता है, पैराबोला. सो प्रोजेक्टाइल मोशन इज अ पैराबोलिक मोशन. ओके, सो द प्रोजेक्टाइल मोशन इज अ पैराबोलिक मोशन. नाउ वी विल discuss three important points that are often asked in the exams. That is flight time of the projectile, height of the projectile, and the range of the projectile. Okay. So first we will discuss flight time. Let us take that the body takes t time to reach the highest point P. T is the time taken by the projectile to reach the highest point P. Now this motion, vertical motion, is under acceleration due to gravity. So we use the equation V is equal to u minus at. V is equal to u minus at. Now at the highest point the final velocity is 0 and initial velocity in the vertical direction is u sin theta. So we put this equation V is equal to u minus at. V की जगह क्या आ गया 0, u की जगह क्या आ गया u sin theta minus gt. T comes out to be u sin theta upon g. तो हाईएस्ट पॉइंट तक रीच करने के लिए कितना टाइम लगा, u sin theta upon g. तो जितना टाइम हाईएस्ट पॉइंट तक पहुंचने में लगा अंडर द एक्सेलरेशन ड्यू टू ग्रेविटी, द सेम टाइम इट विल टेक टू कम डाउन. तो कंप्लीट टाइम क्या हो गया, 2t. तो टोटल टाइम टेकन बाय द प्रोजेक्टाइल टू रीच द फाइनल पॉइंट ऑन द ग्राउंड इज 2t. इट इज इक्वल टू 2u sin theta upon g. Okay. So total time of the flight is 2u sin theta upon g. Then next we have height of the projectile. Again, the maximum height is the point P, and this motion is again under acceleration due to gravity. So we will use the equation of motion. We need to find out the height. So we will use the equation V square is equal to u square minus 2gh. The final velocity at the highest point in the vertical direction is 0. So we will take V equal to 0 and substitute the value of initial velocity in the vertical direction, that is u square sin square theta minus 2gh, and we find out the value of h. So h is equal to u square sin square theta upon 2g. So total maximum height of the projectile is given by the formula h is equal to u square sin square theta upon 2g. Then we have the range. Now what is range? The horizontal displacement of the projectile, or the maximum distance covered by the projectile. Now we know that the horizontal velocity remains constant. The horizontal velocity remains constant, and the total time taken by the projectile, the total time of flight is t. So we put the value r is equal to ux into t. Horizontal velocity क्या थी? u cos theta और t क्या था? 2u sin theta upon g. So we multiply them. We get u square 2 sin theta cos theta upon g. Now we have the formula in trigonometry. 2 sin theta cos theta is equal to sin 2 theta. So we substitute that. We get the formula r is equal to u square sin 2 theta upon g. Okay. Now there are certain cases. We get the range. R is equal to u square sin 2 theta upon g. Okay. Now what do you want? We want the maximum range. सबसे ज्यादा दूरी पर जाके गिरे. तो इस फॉर्मूले में अगर हमें मैक्सिमम रेंज चाहिए तो sin 2 थीटा की वैल्यू क्या होनी चाहिए? 1. साइन की वैल्यू क्या होती है? मैक्सिमम 1 होती है. तो sin 2 थीटा की वैल्यू क्या होनी चाहिए? 1. तो 2 थीटा शुड बी इक्वल टू 90 एंड थीटा शुड बी इक्वल टू 45. अगर आप 45 डिग्री के एंगल पर हॉरिजॉन्टल से किसी भी चीज को फेंकेंगे तो सबसे ज्यादा दूरी पर जाके गिरेगी. समझ आ गया? अगर आप 45 डिग्री पर किसी भी बॉल को किक करेंगे along the from the ground, then it will cover the maximum range. And there is one more point. What is it? We know that sin 90 minus theta is equal to sin theta. Sin 90 minus theta is equal to sin theta. So we come to know that if we throw a ball at an angle theta or at an angle 90 minus theta, the range will be the same. Okay? अगर हम किसी भी बॉडी को थीटा पर फेंकें या 90 माइनस थीटा पर फेंकें, रेंज क्या रहेगी? सेम रहेगी. For example, you can see in the diagram in the book, the ball is kicked at an angle 30 or at an angle 60. They will fall at the same point. Okay? 30 डिग्री पर किक करें या 90 माइनस 30 60 डिग्री पर किक करें तो दोनों कहाँ जाके गिरेंगी? सेम स्पॉट पर जाके गिरेंगी. Then this is when we are throwing a ball just above the ground. But suppose somebody is at a certain height above the ground, like a volleyball player. You cannot consider him just above the ground. So, for a maximum range, the volleyball player should throw at an angle slightly smaller than 45 degree. Okay? अगर किसी हाइट पर किसी हाइट से किसी भी चीज को फेंका जा रहा है तो एंगल ऑफ प्रोजेक्शन क्या होना चाहिए? स्लाइटली लेस देन 45 डिग्री फॉर द मैक्सिमम रेंज. ओके. नाउ दैट इज गिवन. अर्लियर वी हैव डिस्कस कि एक एग्जांपल दिया हुआ है. एक मंकी है एक पेड़ पर. दिस मंकी इज सिटिंग ऑन द ट्री एंड देयर इज अ कैनन, तोप, और तोप से मंकी को उड़ाना है. ठीक है. तो तोप को हमने कुछ दूरी पर रख दिया और उसके बाद जैसे ही मंकी ऊपर से गिरना शुरू होता है वैसे ही हमने तोप को चला दिया. तो क्या तोप का गोला मंकी के टकराएगा? Will it strike the monkey? Yes. The bullet, okay, the shot will strike the monkey. Okay, the shot will strike the monkey. Why? The reason is that both the shot and the monkey are falling freely under gravity. Okay, both the shot and the monkey are falling under gravity. Next question is कहाँ पर टकराएगा? ये इस पर डिपेंड करेगा कि शॉट का इनिशियल वेलोसिटी क्या थी. जितनी ज्यादा इनिशियल वेलोसिटी होगी उतनी ऊंचाई पर वो जमीन से मंकी के टकराएगा. समझ आ गया? So since both the monkey and the shot are falling under gravity, so the shot will strike the monkey. Next we will discuss discuss projections from a height. So let us take a particle that is to be projected from the point O at height h above the ground. The velocity of the projection is u at an angle theta to the horizontal. At an angle theta to the horizontal. So this is the angle theta to the horizontal. We will resolve this velocity into two components, u cos theta and u sin theta. U cos theta will be the velocity in the horizontal direction and u sin theta will be the velocity in the vertically upward direction. Okay. Then we will find out the time of flight. So considering vertical motion from O, we will use the equation of motion s is equal to ut plus half gt square. Height is h. H height it has to come down in the opposite direction. तो velocity को हमने उल्टा कर दिया, vertical velocity को उल्टा कर दिया, minus u sin theta into total time of flight t plus half gt square. From this equation we can find t. ठीक है, इस equation में अगर हमें height दी हुई है, height मालूम है कितनी height से फेंका गया है, vertical velocity क्या थी, u sin theta नीचे आ रहा है इसलिए minus u sin theta, total time of flight plus half gt square. In this we can calculate. Then we have range. At what distance it will fall. So range is given by the formula horizontal velocity into total time of flight. Horizontal velocity क्या थी? U cos theta into total time of flight. This will give you the range. Now particular case of this range. मान लिया the projectile has been thrown in horizontally. Theta is 0. Okay. If theta is 0, in that case the time of flight will be given by h is equal to ut plus half gt square. Now u is 0, u cos theta is 0. Then t will be equal to 2h upon g. T will be equal to under root 2h upon g. So we will put the value of t here. और किसके होगा ut, u into under root 2h upon g. Then we have the equation of trajectory. Let after time t, the projection from A, the particle is at P, taking O as origin. The coordinates of P are x and y. X is equal to ut and y is equal to half at square, half gt square. So projection क्या है? X is equal to ut and y is equal to 0 plus half gt square. So we eliminate t. x equal to ut है, यहाँ पर क्या x equal to ut and y is equal to half gt square. किसी कोई भी पॉइंट हमने t यहाँ पर मान दिया जिसके कोऑर्डिनेट्स क्या हैं x और y. ठीक है, तो यहाँ पर x की वैल्यू क्या आ गई ut और y की वैल्यू क्या आ गई हाफ gt स्क्वायर. दोनों से t को एलिमिनेट कर लिया. इक्वेशन क्या आई y is equal to half g x square upon u square. Again this is an equation that has got one variable to the power 2 and the other variable to the power 1. So this equation also represents the parabola, equation of parabola. So the trajectory is parabolic in nature. Okay. The last thing that we have, effect of air drag on projectile motion. Here we had assumed that air resistance is 0. Okay. So if there is the presence of air resistance, then what will happen? Both the horizontal and the vertical velocities will be reduced. As a result, both the range as well as the height, maximum height achieved, will be reduced. Is it clear? If there is a resistance or air drag, in that case, both the vertical height and the range will be reduced. So we complete with this lesson. Now, my dear, there are solved examples. Go through the solved examples and solve the